So, um, first of all, I have updated the assignment, and sorry about that. Sorry that I had to do that. Lighting settings are. Is this lighting okay? No. All right. What's going on? So for the assignment, I noticed, so this used to be L plus 1. I noticed that the solutions weren't that diverse with this setting, right? Even though the problem wasn't conceptually wrong. So I changed it to L divided by 2 plus 1, which should not make significant changes, right? If you coded if you wrote your code faithfully according to the problem, you should just change a formula and obtain new values, right? In describing the solution, because there were some students who seem to have a different understanding of the solution, but they're not here right now. I'm also describing the solution in detail, right? For every solution, I'm also describing the jumps, so then you can check exactly what's happening. So all you have to do is to produce this column of numbers, right? 1 here. So whatever happens in this part of the text, I wonder if I can just select the column, but I'm sure I can, but I don't know how. So it would take some time to find out. So I'm not going to try to find out that right now. But this column that you see right here, these are the results that you have to return, right? The rest is just information that is trying to help you debug or understand the solution if necessary, right? So let's go to one that has many jumps, right? Let's say this one. So first time we jumped 21 length units, and that's because of distance from the destination or to the destination, right? And then we further jump 10 units, or the frog jumps 10 units, again because of distance from the destination, right? And then 5, and then 3, again because of distance from the destination. We have 2 rules, and we want to figure out which rule applies. Let me find one that actually has origin. Okay, the last one has origin. So we first jump 32 steps because of the rule about the length from to the destination. Then we jump 17 steps because of the rule about the distance from the origin, right? Then another 8 steps because of the rule about the distance to the destination, and then another 4 because of the destination, another 2 because of destination, and so on, right? So if you want to understand why the solution is what it is, right, you have a description of it. You do not have to produce that output. All you have to produce is the number that is given here, right? So just a function that produces an integer, that returns an integer, and right, whenever I pass in the argument 10, your result needs to be 2. That's it, right? The information here explains why the result is 2. Okay? Okay? Cool. All right. So let's continue on with our lessons. So last time we learned about scopes. And we learned the difference between a function and a procedure, right? A procedure can hide variables inside its own body, right? And can keep updating those variables while they remain hidden, right? Also, we were making the argument that Python is very useful because of its predefined built-in functions, right? Because it's a built-in library, and that the library is large, so we have to deal with modules and packages. And we're going to find out more about that later. So last time we have created an adder. All right. We learned about non-local symbols. Right? We learned about non-local symbols. So then here you have an explanation of what non-local symbols are. And let me remind you, in our case, when we created the adder, we had to provide this declaration saying that this variable is not defined inside int x, is defined outside of int x. All right? So remember that. Okay? So every variable has a scope. And without a non-local declaration, the scope is always the innermost procedure where the function is defined. We're going to try to play a little bit more with these, right? And try to make an argument about aggregation of data, right? Understand the concept of aggregating data. So let's see a different type of Fibonacci. So we have a function called, a procedure called make fib, right? So let's create several fibs. We don't have arguments, right? So we create one fib. And now, if I say f, oops, what does f need? F1, of course. Call it F1 and then I come in. F1. So then we get the first Fibonacci value, right? We call F1 again, we get the next Fibonacci value, and the next Fibonacci value, and the next Fibonacci value, and the next Fibonacci value, right? This approach we're going to revisit later, right? And it's very important for us because we don't get all the values at once, right? We get the sequence of values but one at a time. And this will have to do with our concept of laziness. Later, we're going to talk about generators. But look what happens at this point. What I want you to understand is, look what happens if I create another one. If I call fib f2, what are we going to get? 1, right? Why? Because the variables a, b that allow me to compute the Fibonacci values, right, are local to make fib, right? They're not global. So every time I make a new fib, I get a new instance of the variables a and b, right? And then I'm going to have two Fibonacci generators, each of them going at their own speed. They're completely non-interfering. They don't interfere with each other, right? They're completely independent. Is this clear? Right? Okay. Is this clear? Is it clear why it computes Fibonacci? In order to compute Fibonacci, we always need to remember the last two numbers. Not the last one, but the last two, right? So the variables a and b do exactly that. They remember the last two values of Fibonacci. Then, in order to compute the next value, we just have to add the last two values. For some reason, this editor doesn't recognize the mouse anymore, right? So, yes. Yes. All right. So, important question now. Let's say I forget about F1 and F2, and let's say I forget about F1 and F2, and I go on and do some other computations. How long will the A's and the B's from make fib last in memory? Until I quit, right? Very good. So essentially forever, because there's no guarantee that I will ever quit. So essentially forever, right? What should we be doing to discard them? Well, can I not be so drastic? Can I do something less drastic and still? So quit is one correct answer. It's not the one I would typically want to do, right? I would like to continue using Python, but still reclaim the memory that I'm using, right? Very good. So that's one possibility, right? So I could say something like f1 assigned none. So we're learning this value, none. So it is a Python value, it is a legal value, but it represents no value. Okay? It's very similar to 0 for numbers, just that 0 is a value. 0 is not a quantity, but it is a value, abstractly speaking, right? It's often commented that 0 is one of the greatest inventions in mathematics. It happened many millennia ago, apparently, in India, and it was the Arabs who brought it in, right, including with the rest of the digits that we currently have. So they're called Arabic numbers, right? Sometimes our digits they were actually invented in somewhere in North India, if we believe the Wikipedia page. All right, you shouldn't always believe the Wikipedia page. But it's an important kind of abstraction, right? Because it seems like you're giving something when you're giving nothing, right? You can say you don't say anymore, I don't give you anything, but I say I give you 0, right? So the act of giving nothing can be conceptually treated as if all the other cases of giving something, right? And right after that, come the negative numbers. But this is an important question, right? Sometimes we don't want to return anything. We don't want to give any to the outer environment, to the user. We don't want to give anything, right? How do we do that? Well, we create this abstraction of none, and we give them none, and we can do that. What happens at this point? Well, there's a relatively complicated chain of references. You see, previously, F1 was referring, so we have this concept of global environment. So this was pointing to F1, which in turn was pointing to A. And I can draw a separate diagram with F1 pointing to B. F1 points to both A and B, right? And everything that is referred from somewhere is being kept in memory. So that's the rule. In general, we will have much more complicated reference chains, right? Global environments points to some X, which points to some Y, which points to some Z, and we can have thousands, actually, of elements in the chain, right? As long as one of those elements is pointed to by something else, it is kept in memory. So, in order to have it deleted, right, we destroy this chain, right? By saying F1 is none, we destroy this chain. At that point, A is automatically deleted. At that point, we say that A becomes garbage, and garbage gets collected. So, garbage collection is an important concept in computer science. All right, you must have heard of it, right? So we don't collect the garbage immediately. That's also an important concept. It's more efficient to wait until the garbage is piling up and collect it all at once. Unlike, your parents must have told you be tidy, so clean up after yourself all the time. The programming environments don't do that. They allow the garbage to pile up and up and up, and at some point they collect it. Right? And it's easy to collect because you just override the memory with zeros and, it's done. But it's easier if you do it all at once instead of one item at a time. Okay? So, a much better way, so one way is to do this. And anything I would do, instead of saying none, if I would have said F1 equals 1, that would still have deleted the A inside F1. We still have the A inside F2, right? That has not disappeared yet. But it would have been even easier to say del F1, at which point F1 doesn't exist. So what we have done here is was pointing to F1, which was pointing to A. So at this point, we have destroyed this link. When we say del F1, we have destroyed that link, right? And then what happens? Well, nobody points to F1. So at some point, F1 will get garbage collected. And along with it, anything that it points to. And then A is not pointed to, is not referenced by anything. So then A gets garbage collected, right? So garbage collection is sort of a chain reaction. We start from the top and we see, oh, this guy is not referenced. Remove it. But by its removal, some other stuff gets to not be referenced anymore. So that stuff gets removed. And then by chain reaction, a lot of the memory gets freed. So sometimes you might have a chain of maybe thousands of elements, and just by deleting the first one, you trigger a chain reaction of collecting the garbage and removing all the elements and actually freeing the entire memory space. Yeah. Just Razvan. Okay. No. No. So don't delete. Yeah. But normally you have your program in your file, so you can always restart your program, right, and recreate the data. So how again? Well, it's not a. We don't need to throw away anything. We just need to overwrite, right? So that's the. We try to create these parallels between what the computer does and what humans do, but in this case, you see, processing data doesn't result in residue, because typically what we do is we use the objects around us until they become unusable. That's residue, and that needs to be thrown away, right? And they can be recycled, of course. They can be sent to some place that turns that stuff into new stuff. But here, all you have to do is overwrite the memory, right? Just that we have to overwrite it carefully because we have to separate the garbage from the non-garbage. And they are, garbage and non-garbage at any point are interspersed. There's areas of memory that have garbage and areas that don't, followed by areas that do, followed by areas that don't. So if we try to do it one item at a time, we have to always tell the global memory management, oh, notice that this is now not garbage. And it seems like a small operation, but actually, if you would study the data structures that are involved in that operation, you would figure out that it's a non-linear operation, right? It's not a constant, not non-linear, not constant operation. It's not a constant time operation. Every time you spend more than one operation on doing that, right? Whereas if you aggregate many operations at one go, you can actually save and you can get near linear, right? You have n items to be garbage collected, and you spend almost a number of operations equal to proportional to n. We're going to discuss complexity later, and we're going to understand how to gauge the time required by an operation. Oh, yes. No, typically will stay around, but you have no control to when it does. Typically, it will be a new way. So you have no control to when it's garbage collected. You also have no access from the point you have dereferenced it, right? So it's completely up to the. So the main objective of the memory management system is that you don't run out of memory. So at the point when you almost run out of memory, that will trigger a garbage collection phase, right? So the system will stop for a while and go and collect all the garbage, right? And tell the interpreter, oh, now you have this entire cluster of memory locations that is available for you, right? So it really doesn't matter. You might as well consider it disappeared at the point when you deleted it, because from that point on, you will not have access to it. The program will not have access to it in any way, right? So the question, when should it be garbage collected, is if you were implementing a Python interpreter, then you would want to know and design that. But if you're a user of Python, it doesn't make a difference to you. Cool? All right, let's try to apply this in a different way. So I am going to define another type of maker. I'm going to call it pair. And it's going to take two arguments, and I'm going to say if, sorry, of index all right, so let's see what we get from this one. Actually, I should have just F5'd it, but it doesn't matter. So let's say P1 all right, so if I say P1 applied to 0, what do I get? One, right? If I get P1 applied to 1 or any other value, I'm going to get 2, right? So you see P1 is, and similarly, P2 applied to 0 is going to get 2, P2 applied to 1 is going to get 3, right? So P1 is a single object, but it has two other objects inside. Is that clear how this works? And this is what a pair normally is. It's an aggregation of two values. Okay? So, no? So P1 is a single object, right? I can treat it as an entity. But inside it, there are two other objects, right? So this is an example of aggregation. So aggregation is, on one thing, is conceptually simple to do. I can very easily come up with a function that will do something like this for 3 values, right? And I can make it even more meaningful. So let's say I have a helper and I get a let's say component here, and I can say if I equals first name, right, return a. So let's actually be, this is not, we call this make person, right? So this is first name, fn, last name, maybe age, right? So we're going to return the first name, else, elif, I equal last name, we're going to return ln, else, we're going to return age, right? So let's do F5 on this, and let's say John equals person, make person of and 10. Okay. Let me make this a little bit smaller. Maybe it's easier for you to see. And then I can say applied to first name without. I'm going to get I is not defined. Of course, I is not defined because we should have set component, right? So John Smith applied to. Oh, okay. So make person first, and John Smith applied to first name. We get John, right? And if I'm going to say last name, I'm going to get Smith. And then if I'm going to say John age, I'm going to get 20, right? So John Smith, this variable here, John Smith, is a single entity, but it has 3 other subcomponents or components inside, right? And it's important to aggregate it. It's very easy to see why this is useful, because John Smith is just a person, but it has all these features or attributes. It has names, it has age and address. Yes? Here? Yes. Well, I am returning it to outside, right? I'm not calling helper. Helper will be unknown here, right? No. We define make person. Make person returns helper, right? So whatever is returned here becomes the value of this guy, right? But there will be an instance of helper for every invocation of make person. So I invoke make person here, I will get 1 instance of helper, right? It's like this helper is created when make person is executed. So make person gets executed. We define a helper inside, and that helper gets returned. We invoke make person again, a new version of helper gets defined inside and gets returned, right? So for every person we get, we're going to have a different helper, and that helper will have precisely access to these variables, which are going to be different on each invocation, right? So, but if we try to do make person and then give it an argument of person, that would not work. No. So make person is expecting 3 arguments, right? But one thing I can do, make person and then 2 values? Yes, that would work, but that would be useless, right? Because so let's say I say age here, and then this guy and this guy have been lost. They've been garbage collected. They've been marked for garbage collection. They have become garbage right away. Why? Because nothing is pointing to them. I don't have a variable that points to the result of make person, right? So this kind of use, even though legal, it's not useful at all. Cool. Does that convince you that aggregation is useful? It's important to put many values together. Okay, so that's what we're going to try to do later. I'm going to skip the combinations and the Pascal's triangle. They are fun pieces of code, and feel free to run them on your own. All right? Yes? What do you mean to record? I'm not sure I understand the question. Can right. Right. But helper doesn't really exist, right? Here. Helper is in the inner scope. We just discussed that whatever is in the inner scope is not global. So helper What is not a function? It is. It is an instance of helper. You see, it's not the helper. It's an instance of helper. Because there will be many helpers. Right? So this helper, where were we? This helper does not exist outside of MakePerson. But so try to distinguish between the name helper and the value of helper, right? So when we say def helper, that has two aspects to it. We define a name, which the name is helper, and the value of that helper, the name of a variable, right? And the value of that variable, of that helper, is the procedure, which is here. This is the body of the procedure, right? So the name doesn't leak outside, but the value can leak outside. There's no problem. We are returning it, and it becomes the value of John Smith here. Does it make sense? Something like that, yeah. Okay? Yes? It's an instance of helper, right? Because that's what you're returning, right? So you can look at this as a blueprint, right? This is a blueprint. Of this blueprint, one instance is created on every invocation of MakePerson. Does that make sense? And that's what gets returned outside and becomes the value of John Smith. Right? Now we're gonna go to object-oriented programming, where we're going to see a very similar concept, and we're going to say at that point that this will become the class name, right? And this will become what we call the constructor, and we're going to say that John Smith is an instance of this class, and that's the standard terminology for object-oriented programming, right? But if we think of the blueprint for the object, the blueprint of the object is the helper, right? Perhaps it will help a bit more if we didn't call this helper, but rather person. Right? Would this be more yeah? Okay. So we're making a person, and then therefore we are returning a person that has just been constructed. Cool? Okay, because before we go any further, let's learn a new kind of construct. All right? So we learned about the break statement last time, right? And there's a very interesting statement or clause that can be used in conjunction with break, right? So every time we have a while loop here, every time we exit with break, we completely exit the loop and move on. But if we exit this while loop without having executed the break statement, then we would also execute this print, this else. All right? So if we execute the break, we just move out of the loop completely. But if we don't execute the break, then we get to execute the else. Okay, so let's try to execute this little program, which again doesn't have a procedure. So again, we're deviating a little bit from our right? So we can execute it multiple times. Okay, I really have to find a better way of, no, here. All right, so let's look at what the program is doing. We're going to use random numbers because we might as well introduce this as well, right? So we're going to start from an arbitrary number, and we're going to iterate through 50 numbers, right? So we start here, and we stop at that number plus 50. And if we find a multiple of 101, 101, happens that 101 is a prime number, so there aren't that very many multiples of 101, then we would say found multiple of 101, right? And at that point, we execute the break, and because we have executed the break, we don't execute the else, and our code is done. However, if it so happens that we pick a start interval so that the next 50 numbers don't have a multiple of 101, right? Then we're going to continue executing until this becomes false, right? We're going to keep executing until this becomes false, at which point, upon exiting the while loop, we're going to execute the else statement, and we're going to print no multiples of 101 found. Okay? So it's an interesting application. There aren't that many that where you would find this else clause useful, right? It took a while to figure out one that at least has the resemblance of one that where this kind of thing would be useful.
So the reason why you put break is because the whole purpose of code is to find that 101.
Yes.
So once
right.
you find it, I'm done.
Yeah. Once you found a multiple of 101, you're done, right? That's what you want to print, and you don't. Well, you only have 50. And 101 is a prime number. So you're only going through 50 numbers. If you found one, you're not going to find another. But let's say that you just want to find the first. That could be equally, I mean, it's not a very practical problem, right? So you could give it whatever meaning you want. Okay? So you say, I want to find the first multiple 101. Let's say you use a different number, not a prime, and you use two different numbers, right? One, instead of 101 something else, instead of 50 something else, and then you would be exiting on the first multiple, right? You just want to find the first one. Yeah? Well, no, I mean, it will keep on printing multiples, but in this case, there will be only one. Yeah, but it will also print the no multiples of 101 found, right? Yes, because you haven't executed a break statement. Right, so if I remove the break, since no break has been executed, well, now we have the luck of, right? So we get here and do the print, but since we haven't executed any break, we haven't executed any break throughout the execution of the entire while loop, then it will say, oh, no breaks have been executed, then we should execute the else. So the else gets executed as well. Again? Then you would have situations where you don't print anything, right? If you don't find any, then there's no print. So you don't really know what happened, right? This is... Oh, if just the else, meaning if this was... Yeah, so yes. So in that case, the else is essentially doesn't do anything, right? The else could be missing. That's your point, right? I was thinking that you would delete the else and everything inside the else, and then you wouldn't print anything. Yeah. So the next this one does exactly the same thing, right? So I want to teach you how to code this without the else. What if we didn't have the else for the while, right? So then we invent an extra variable, which we call it found in this case, right? But depending on its meaning, you might give it a name that is meaningful, and we set it to false initially, right? And we can do the while loop, and whenever we find what we're looking for, right, we set found to true, and at the outside of the while loop, we check whether we found something or not, right? So if we did, we print. If we didn't, we don't, right? And now you might wonder, what if the break didn't exist? Well, I can always go here and say n not found. No, I'm just telling you so that you create a connection, right? Obviously, you should use all the language features that are afforded to you, but there will be languages that don't have a break, for instance. What would you put? Oh! You're right. You're right. This should be and. It's Python. It's my mistake. Yes, I'm not using Python as much as I'm using other things. So.
But why are you considering things where you can't use else?
I'm just saying. So Python is not the only language in the world, right? So, because we have discussed in the very beginning that only lambdas and we only need lambdas and ifs, right, and regular expressions to be Turing complete. We have all the power that a computer can give us with just that. Lambdas, ifs, and expressions, right, which we have learned in the first lecture, right? So the question is, why do we need everything else? Right? So obviously else is not necessary to have full-fledged computation. We need it for convenience, right? So you're saying, why not type else? If the language at hand has it, by all means use it. Not all languages will have, and I am trying to give you the tools to, potentially progress to different languages if you ever need, right? You're probably not thinking that far ahead, but languages tend to die, right? They tend to come in fashion, and then they tend to die. So there are, for instance, these languages: Fortran, COBOL, ALGOL, Modula, PL1, which were in very advanced, because they're very advanced in the early 70s, right? Nobody knows them. Ada, another very fashionable language. Nobody even knows them of their existence. Pardon? Which one? So Python is gaining popularity. I think Java is still probably the most popular, though it's declining. So Java popularity is declining. But if you look at then C and C++ have been quite at the same level for many years. So they were very fashionable in the 70s, and they have remained languages in use. So they still are above 10% of the market. I think Java is somewhere in 25%. Python is gaining popularity, is also in the 20% percentile. If you look at the statistics, no, they're not doing that well, right? So Scala is rising. So I'm a Scala coder, by the way. I would love to see more Scala being used. But Scala is rising and somewhere at 2%, and it has gone up, right? Haskell is below 1% and has stayed there for many years. Before being a Scala coder many years ago, I was a very, very fervent Haskell enthusiast, right? And I would have liked at that time to see more Haskell being used. Unfortunately, I'm quite convinced now that that's not going to be the case. Um, JavaScript is a language, is also a very popular language. It's not a good language. You have probably heard that many times. It is what it is. It evolved in a very chaotic way, but it's a language that you, if you're a coder, you can't ignore. Because in the end, you will need to put some information on a web page. So you can't ignore JavaScript. OCaml is worse than Haskell, actually, right? So interestingly enough, Facebook has more OCaml projects than it has Haskell projects. Okay, and a very old friend of mine has joined Facebook in London to work on a program analyzer that is in OCaml. And apart from, there's this company called Jane Street Capital in New York that uses exclusively OCaml for algorithmic trading, for everything, but mainly for algorithmic trading. And this is the only industrial shop, business shop that uses OCaml on large scale. Everything else I know about OCaml is academic projects, not small academic projects, so really serious projects, but they're exclusively academic. So OCaml in practice, I don't know. You do learn OCaml as your first language, right? Because I've been teaching in the previous semester, I've been teaching a compiler module here at Yale NUS, and I've been doing it in OCaml, right? From one end to the other, and that's because the students that I had knew OCaml quite well, right? That's because of the introduction to OCaml. So I don't think it's a bad choice as a first programming language. So I think, for instance, Python is worse. But it's not, you're not going to see a lot of use of OCaml in the remainder of your career. So be prepared for that. Yeah. Where is it? If you go to popularity of programming languages, you haven't done that before? So there's the programming language index. Yes. So here we go. Well, when I was saying 20%, I was actually exaggerating. But you see, so Java is at 12, but it's changed. It's dropping -6. Oh, Python is down. Good for you guys. So Go is very up and coming. I'm forgetting Go. Go is very up and coming. Go will rise into the between 10 and 20%. Yeah. Pardon? Can I find OCaml? No. There will be. Oh, I was a Prolog enthusiast somewhere very long ago. So Prolog is better than OCaml? That's interesting. So Haskell is here. And OCaml not. But you see, F# is here, and OCaml is pretty much F#. F# is pretty much OCaml. Right. Oh, well, there's many answers, and for me, there's many reasons. You see, the popular languages are supposed to restrict the coder so that it doesn't do typical mistakes. It doesn't make typical mistakes. All right. And in that, it restricts the creativity and right. So take Java for instance. Java was done by a guy who was sick of C++. All right. So thought that C++ was such a rich and powerful language, but it allowed people who weren't very competent to introduce bugs in the code. Right. When you have millions of lines of you have a code base with millions of lines, one bug can cost you a lot. Right? You you notice that it exists, but finding exactly where it is in the code and how to fix it can be very costly. It can be many people over many weeks and sometimes months. So that may cost the business a lot. So they were trying to restrict, to take away from C++ everything that was potentially harmful, right? And they created a very dull language. It's not fun, right? Because of the dullness and of this perceived safety, especially the finance sector has embraced it, right? So they only hire Java programmers, right? So then, where there's demand, there will be a supply, right? So a lot of people went and learned Java and became Java programmers, right? And it's a business requirement that creates the popularity of the language. So people who know nothing about programming, they hear various things about various programming environments, and they say no. They put their foot down. I want my software to be developed in Java, right? So they will find project managers who will find the coders. They will assemble teams. They will start coding in Java, right? And that's what makes the popularity, especially of this kind of environment. So Java, C#, these are industrial level languages. They were created by corporations. They were created to be popular, and they were created specifically to address various business needs, right? So the demand for these languages comes from business people rather than system or software engineers. So popularity is not always the coolness of the language. The less popular, and typically the cooler the language. Python is different. Python has completely open source development. So the author of Python created it as the language he would have liked to learn as the first language, right? And he put it out there, right? There was a lot of enthusiasm from beginners, right? And the beginners who learned it stuck with it and helped it develop further, right? So it became a language nowadays that has everything available. So whenever something becomes available as a technology, it first becomes available in Python, right? Python is generally more cutting edge than many other programming environments, precisely for this reason. It has a critical mass, and people want to contribute, right? And it's more the desire to contribute and push things forward rather than the coolness of the language that keeps the community going and keeps this being bleeding edge. So again, it's not a language that I, as a professional, would like to ignore, right? So it's a language that I want to know well, and I want to know what's going on in it, so that perhaps I will take that stuff that I see that is bleeding edge and port it to Scala, for instance, and be the first to create that in Scala. But generally, bleeding edge stuff does happen in Python much more than in any other language right now, right? This is why it's so popular. Until a few years ago, R was the language of data science, right? So most of the software that or the APIs, right, that were useful in data science were first made available in R. That's no longer the case. They're first made available in Python. Python has by far the most extensive data science library for machine learning, for anything you like, for data munging, for creating web pages. So it's not a language you wanna ignore again, right? And it's also a language that is easy enough to learn. It's also a language in which it's easy enough to make mistakes, right? Which is why I think, for instance, a language like OCaml is a little bit better in that respect, right? Because it is very powerful, but unlike C or C++ or Python, has the mechanisms to provide safety. Those mechanisms for providing safety, which is the type system, are sophisticated enough that they're not for the faint of heart. Well, unless you're a computer scientist, you're really interested in becoming a professional coder later, right? Or becoming a researcher in computer science, or having a deep interest in computer science, it's probably not the thing that you want to do, because you will never be coding at that level. So, right? So you want the power, but you also want the protection. That's very difficult to achieve. It creates languages that are conceptually complicated, right? And yes, MATLAB is not that much different from Python, right? Not that much different from Python. At least not. Again? Yes, it will have less functionality than Python, but in the ease of use, at least at first contact, it's a really easy language to use. You have types. You can work with matrices and vectors off the bat, right? Which you can't do in Python, but in Python would have libraries and would have data definitions for matrices and vectors that can be used, you know, off the. I mean, I can just import NumPy or pandas, and I have matrices or everything I need to do. Yeah, does that make it clear? Cool. So back to Python. Okay, this else is a detail. All right, let's learn the continue statement. So the continue statement is the opposite of break. Instead of breaking out of the loop, what it does is it skips the rest of the current execution of the loop and goes back to the top, and then continues with the loop. All right. So whenever we reach here and execute a continue, we're going to skip the count plus 1. All right. So we're doing now a similar program to the previous one. We are counting numbers that are not multiples of 2 or 5, right? Of which there should be many, because 2 and 5 are relatively small numbers, right? So we take a sequence of 50 numbers, and we count how many non-multiples of 2 and 5 we find, right? So how do we do that? Well, we start with a count of 0, right? We keep increasing our counter, our index, right? This I gets incremented every time, and we're going to do this precisely 50 times, right? This is the condition, and we're going to increment I every single time, right? And then every time we find a multiple of 2 or 5, we execute continue, which will make us skip the count. All right? Is this clear? Okay. So again, not my favorite style of programming, but sometimes useful. And it's a relatively common construct in many programming languages. So you might as well learn it. And perhaps we should have said what is the start interval as well. That might be a useful thing to have. Okay, so you can see that there's large numbers, but typically we're going to find either 20 or 21 non-multiples of 2 and 5. Right, so if you think very carefully, 25, 2, there will be 25 multiples, right, of 2. And then for 5, because we have 50, there will be either 10 or 11. Right? But of those, actually 5 are both of 2 and 10, so we have to subtract 5. So we're going to find either 10 or 21. Okay, is it clear how this works? So the essence is that continue skips the rest of the loop. and continuous executing. Okay? Of break, right? Break would exit the loop. Continue is sort of the, I don't know, the opposite, the dual, maybe, right?
Why do you continue? Would it do it by default?
Well, how do you skip? If I don't have continue there, how do I skip the count +1, right? I'll have to have an else, which would be the way to replace continue, right? Why XOR? So I can negate this. I can say no. How do you negate this? This is how you negate this. Have you heard of the De Morgan rules? You can of course say not, but that's what beginners do. Alright? Or you can negate properly. Right? So A or B is negation of A and negation of B. And vice versa. Right? So I could do this and then say count, instead of continue, I could say count plus equals 1, right? So that would be equivalent. That would be perfectly equivalent with what we had before. Right? But would not allow us to explain what continue is. So. Okay? So, break and continue just save us some if conditions, essentially, right? So some people would prefer them, and if you do, feel free to use them. If you don't use them, right? Not all languages have them. So for instance, Scala doesn't. We will learn many other ways of performing repetition where actually break and continue will not be available. So don't rely on them too much. The pass statement, which you have seen in the assignment, pass does nothing, but nevertheless takes time. So if you want to do a busy wait, consuming a CPU cycle, you can do something like this, right? It is useful because of how code evolves, right? So imagine that you have to write a rather long program over a few days, and then you want to provide some structure to your program, and you're going to decide that, I'm going to write a function that is called this and does that, right? And you're going to write the definition of the function, its name, and the arguments, but you don't want to spend the time to build, to write the entire body of the function because you're in the phase of designing, right? So you put a pass there. So pass allows the program to stay, to be syntactically correct, right? Even though it's not functional. Okay, so at least when you put it inside the interpreter, you don't get an error. It's very typically a way of evolving programs, right? You create a structure, you put your functions in there, you put pass everywhere, then you implement a few features, you test those features, you implement a few more features. Every time you implement a new feature, you might remove the pass in a function and replace it with a valid body, right? And you incrementally implement your program. You're going to see pass in your assignments because when I'm giving them to you, they're going to have pass. You have to replace the pass with valid code. Cool? Okay, there's another interesting feature that we have to go through, and that is default arguments. So look at this definition. This again is very useful for professional code. When you play around, it's not so useful. So previously we would just name the arguments, right? Now we are also giving them values. These are not the real values of the arguments, but this kind of definition allows you to omit the values of y and z. And if you omit them, at that point, they will be provided internally by Python with, right, those values will become the default values that are written here, right? So once I have this definition, I can write F10, and this will be valid. This will be correct Python, right? So Python will go to F and will say, oh, I have 10. 10 goes to X, and since I don't have any other values, I'm going to get 1 for Y and 2 for Z, right? But maybe I want to provide a value for Y, so then I can provide that value for Y, right? Or maybe I want to provide a value for each of the 3 arguments. Let's say now I want to provide only a value for Z. I do not want to provide a value for Y. I can specify which value do I want to provide. I want the Z but not the Y, right? Yes?
So the 10 is the value for Z, or is it X?
This is X, right? X doesn't have a default value, so that I always have to provide. And if I don't name it, it has to be on the first position, right? Then Y has a default value, so I don't have to provide that one. But Z, I want Z to have a different value. If I want, I can provide all the 3 values with names, all right? And again, for professional coders, this is very good. Why? You write so many functions, you forget which are the arguments, right? So whenever you see a function called with maybe 5 arguments, you don't know which is which. You can't remember in which order you wrote them. You remember that in function, I need a file name, I need a folder name, I need a network address, I need whatever else. But I can't remember which order I have provided them, right? I don't, right? So then, as documentation for other coders, when you call the function, you call it with all the names, and that documents better the code, right? Makes it clearer later when you go and look at it, which is which, and gives you confidence that you've written the code correctly. Yes?
If you want to be semantic about the writing implementation, you write, is it the same as X is equal to
X is equal to?
none?
Where would you write X equals to none?
Like, is it the same as like on top?
Here?
The definition.
Oh, X is equal to none.
Yeah.
So if you say X equals to none, no, because you see, if I say X equals to none, let's say I do that, right? Then this is legal. And it will always yield an error. Right? I don't want F alone to be legal. I want, if I say this, whenever I call F alone, the compiler is going to tell me I need at least one argument. If I write this, the error is going to be I cannot add anything to none. Right? So none is not, it will go here, it will do none plus something else. I will say, oh, I can't add with none. So that will be a lot more confusing in terms of an error. But good question. Yes?
Is there not a way of like ignoring the Y in the function? Like putting like underscore.
What do you mean ignore? What do you mean ignore?
For example, if is there a way of ignoring, in the sequence, ignoring Y, not giving it a value because of the
So we are doing this here, right?
Yeah. But without specifying, if you like it's like 10, and then you write something for Y, which tells it to ignore Y, and then how much you do.
Oh, I see what you mean. You would like a placeholder.
Yeah, right.
Yeah, I can put 1.
Oh,
No, so I know what you're saying. There's no such thing. Yeah. All right. So you can have now all these combinations.
how
Yeah.
about Y? Would that be
No. Y has to be an existing value. Has to be right? So saying y here doesn't make y defined in the outer environment. If I try to evaluate y here, y doesn't exist, right? So it will be the same thing. If I say just y here, y doesn't exist.
The code will just stop there and be like, what is y?
Yeah. Besides that, I cannot say y. I cannot say 3 here and then z. I cannot say like 7 and then z, right? All the named ones have to go first, and the non-named ones. I cannot mix named and non-named.
So why is this in 10 7 0?
Oh, it won't figure out that that y is supposed to
So
be
then which one is
7. It will say that if you started to name x, then name all of them. So you cannot name a few and then name the rest, or you have to name all of them.
So if we get rid of x equals as well, if we get rid of x equals 10 7
Oh yeah, so then it works. Yeah, so then it works. This will work. But this kind of mixtures in practice, they're never a good idea, right? So either we have a function where we know it's very obvious what the arguments are. So let's say you have something that represents some geometrical thing, and x comes always before y, right? It's absolutely well known. Nobody will ever mix them up, right? So then you don't need to name them, and you use them without names. Or they have very complicated meanings, and you don't remember the order, so then you always use it with named arguments, so then you remember what which is which. What do you mean? Can you tell me where? Which one is confusing for you? Yes. So here. So I'm providing default values. All right. So if in here I'm not providing 3 arguments, the last 2 will get their default values. Okay. So these are little things, but they do help in practice. They make a world of difference. All right. Another thing that is very useful is documentation strings. So we have these strings that are enclosed in triple quotes. So these are very useful strings because we can have inside any kind of characters. So I can write something and then press enter, right? And then press a few tabs. I'm not sure why that's 0.3 mole. I'm not sure why. That must be. I think my idle is right. There's something wrong with it. And then I close the string, and then notice the \n here, right? So the entire multiple line text has been included in a string, which is not the case with a single quote string. So if I put a single quote and press enter, right, I will immediately get a syntax error, right? So end of line cannot be, multiple line strings cannot be enclosed in single quotes. Now, to make things even more interesting, let's go back here and say string s is assigned. Oops, go to the end, right? And now every time I print s, I get this. So notice one difference. People are still confused about print and evaluation, right? So notice how print prints the string exactly as it was originally typed, whereas the evaluation gives me these strange \n. We're going to learn about them at some point, right? Which are exactly at the point where the line was breaking. Right, the line is breaking here, and then precisely in that position we have this \n, right, which we call the new line character. Okay. So if you write full-fledged programs that you have to run from the command line, your only choice is to print. You won't see anything out of the program unless you print, right? In this learning environment that we have here, the interpreter gives us the courtesy of evaluating everything we type in, right? So it's like a helper aspect, right? And we're taking advantage of this because it's just a faster way of working with code while we learn. But be aware that in general you won't. I mean, if you're just doing that data science and you're trying to crunch some small sets of numbers, then it's fine. You're probably going to stay at the evaluation level. But if you write full-fledged applications, that's not going to happen. Okay, so we're coming very close. Let me evaluate this function and then see one interesting thing, right? So notice that there's this string in there, inside of the function, right? This is called the documentation string. All right. So I'm going to use the help function on f, and notice that this string, well, again, not the greatest. Something is wrong with my mouse, right? You see the string, which is actually the string here, right? So the help function applied to any object will try to give us some help on that object, right? But the help is not invented. Somebody has to provide the help, and it's us documenting the function, right? The good news is that everything that is built in already has help strings, right? So I'm going to apply this to some more functions from math import all, and you can say help pi, for instance, right? And you get the help. Now, the very interesting thing is that you're not getting the help for the value 3.14, right? You're getting the help for any real number, right? And we're going to see that, right? If I say help of 1, I'm going to get exactly the same thing, right? This help is telling me what I can do with a number. This actually was for an integer, so it's somewhat different. Let's do help of sign, right? So returns the sign of x, help of x, right? So
Why help of sign is like way too sensitive and help of pi is longer?
So because pi is a number, right? With
I remember.
right, so help of any number, 1.0, will give me exactly the same help, right? What does this tell me? Well, it tells me a lot of things. But for instance, let's learn one thing that we can do here, right? So you see that somewhere here we have this add function. We're going to play with it at some point. So it tells me that 1.0, 2.0 is 3, right? So every time you see 1.0 plus 2.0, internally, Python does this. So it converts this nice expression into an object-oriented expression, right? This has certain advantages later. We're going to see in object orientation, we can define our own object with our own function called add. And then I can do something like my object plus your object, right? Which now is going to not return anything, but when we do that, it's going to return his object, right? Yes. Why is that? Because whenever it sees plus, it performs this function. So as long as I put a function called underscore underscore add underscore underscore inside my object, I get access to plus. All right? So help does this thing, right? But on your functions, help will not do anything unless you provide a documentation. Okay? So we're going to have to try to get into the habit of writing documentation strings for our code. Okay? So we managed to finish our second installment. All right? And I was hoping actually to do a little bit of aggregation, which is next time. So I was preparing the ground for that. That's why I showed you how can we put many values inside an object. So next time we're going to talk about sequences, tuples, sets, and all the means of aggregation in Python. And at that point, the universe of programs that we can write expands considerably, and it's going to become a lot more fun. Cool? Yes? Yes, it does have a documentation string. Good question. So you can say help one dot underscore add underscore underscore, right? And then you get what you can do with add, right? Now, yeah, unfortunately, this is default. This default help doesn't tell you a lot, right? However, 3 is an instance of int, which is a class, the class of integers, right? So because every integer is coming from the int blueprint, int inside has an add as well, right? So I can do help int, and you're going to see a lot of documentation as well. I can do help of add, int.add. And this one is a lot more concise. Says that it returns self plus value. Whenever it says self, we're writing this kind of syntax, 2 point or dot, and then we're saying this, right? So this is a method invocation, and the 2 has the role of self. All right, so this essentially is a function of 2. We're gonna get there. Okay, but so just one more thing. No, it's enough. Because we often say lambda x, for instance, x plus y, right? X plus 1. So for instance, if I do this and apply it to 10, I get 11, right? So this is a bit cumbersome to write. Instead of writing this, I can write 1 dot add, right? So this is a replacement for this guy. Is that clear? So now I can say f is equal to this, and now f applied to 10, 11. Okay? So there's a certain sense of uniformity, and we can pretty much avoid lambdas to a lot greater extent than before. Okay, yeah, so we stop here. If you have any questions and want to stick around, feel free to.